The National Electrical Code, or NEC, does address the maximum allowable distance between a panel and a transformer, specifically concerning a 480 volts to 120/208 volts transformer. NEC Section 450.13 C governs this aspect of transformer installation. According to NEC 450.13 C, the maximum distance permitted between the panel and the transformer is 50 feet. This 50-foot limitation is in place to mitigate potential risks associated with voltage drop, conductor protection, and overall system safety. The code aims to ensure that the transformer is located close enough to the power source or panel to maintain adequate voltage levels at the transformer's primary terminals. Excessive distance can lead to voltage drop along the conductors feeding the transformer, which can adversely affect the transformer's performance and the equipment it supplies. A significant voltage drop can cause the transformer to operate inefficiently and may result in overheating or premature failure. Furthermore, undervoltage conditions can damage sensitive electronic equipment connected to the transformer's secondary side. The 50-foot rule helps to limit the potential for such voltage drops. The NEC also addresses conductor protection in relation to transformer placement. By limiting the distance between the panel and the transformer, the code helps to ensure that the conductors supplying the transformer are adequately protected against overcurrents. Overcurrent protection devices, such as circuit breakers or fuses, are typically located at the panel to protect the branch circuit conductors. When the transformer is located relatively close to the panel, the same overcurrent protection device can effectively protect the conductors feeding the transformer. However, if the transformer is located a significant distance from the panel, the conductors may be exposed to potential fault currents without adequate protection. This can lead to conductor damage, insulation breakdown, and even fire hazards. The 50-foot limitation helps to minimize this risk by keeping the transformer within a reasonable distance of the overcurrent protection device at the panel. In addition to voltage drop and conductor protection, the NEC distance limitation also considers overall system safety. By keeping the transformer relatively close to the panel, the code helps to reduce the potential for accidental contact with energized conductors or equipment. Longer conductor runs increase the likelihood of damage or accidental contact, which can pose a safety hazard to personnel. The 50-foot rule helps to minimize this risk by limiting the exposed length of conductors. It is important to note that the 50-foot distance limitation specified in NEC 450.13 C is a general rule. The code does allow for exceptions in certain circumstances, but such exceptions typically require special permission from the authority having jurisdiction or urge. The AHA is the local electrical inspector or other official responsible for enforcing the NEC. Special permission may be granted if the installer can demonstrate that the proposed installation meets all applicable safety requirements, even though it exceeds the 50-foot distance limitation. For example, special permission might be granted if the installer uses larger conductors to compensate for voltage drop or provides additional overcurrent protection devices closer to the transformer. To obtain special permission, the installer must typically submit detailed plans and calculations to the AHA for review. The AHA will then evaluate the proposed installation to determine whether it meets the intent of the NEC. If the AHA is satisfied that the installation is safe and compliant, special permission may be granted. It is also important to consider other relevant NEC requirements when installing a transformer. These requirements include, but are not limited to, proper grounding, bonding, and ventilation. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault currents to return to the source, which helps to protect personnel from electric shock. Bonding ensures that all metal parts of the electrical system are electrically connected, which helps to prevent voltage differences that could create a shock hazard. Ventilation is necessary to dissipate heat generated by the transformer. Transformers produce heat as a byproduct of their operation. If the heat is not properly dissipated, it can cause the transformer to overheat and fail. The NEC specifies minimum ventilation requirements for transformers to ensure that they operate within safe temperature limits. When installing a transformer, It is always advisable to consult with a qualified electrician or electrical engineer. A qualified professional can help to ensure that the installation complies with all applicable NEC requirements and is safe and reliable. They can also provide guidance on selecting the appropriate transformer size and type for the application. Moreover, it's crucial to remember that local codes and regulations may have additional requirements that supplement the NEC. Always check with the local AHJ to determine the specific requirements that apply to the installation. Understanding and adhering to these codes and regulations is paramount to ensuring the safe and compliant installation of electrical equipment. In summary, NEC Section 450.13 C specifies a maximum distance of 50 feet between a panel and a 480 volts to 120/208 volts transformer. This limitation is in place to mitigate potential risks associated with voltage drop, conductor protection, and overall system safety. While exceptions may be granted with special permission, it is crucial to consult with qualified professionals and adhere to all applicable codes and regulations when installing a transformer. Firstly, NEC 450.13 C directly addresses the distance. Secondly, understanding voltage drop implications is critical. Thirdly, conductor protection is a key safety factor. Fourthly, grounding and bonding are essential components. Fifthly, proper ventilation is required for transformer operation. Sixthly, consulting a qualified electrician is recommended. Seventhly, local codes may have additional requirements. Eighthly, special permission may be sought for exceptions. Ninthly, documenting all aspects of the installation is important. Tenthly, regular inspections are beneficial for maintaining safety. The 50-foot rule from NEC 450.13 C is not merely an arbitrary number. It represents a balance between practical installation considerations and the imperative to maintain a safe and efficient electrical system. The NEC goal is to provide a comprehensive set of guidelines that minimize the risk of electrical hazards while allowing for flexibility in design and implementation. Voltage drop is a critical factor in determining the maximum allowable distance between a panel and a transformer. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. This reduction is caused by the resistance of the conductor and the amount of current flowing through it. Excessive voltage drop can have a detrimental effect on the performance of electrical equipment. It can cause lights to dim, motors to run slowly, and electronic devices to malfunction. In extreme cases, it can even damage equipment. The amount of voltage drop that is acceptable depends on the type of equipment being supplied. Sensitive electronic equipment, such as computers and medical devices, typically require a very stable voltage supply. For these types of equipment, the voltage drop should be limited to no more than 3%. Other types of equipment, such as lighting and motors, can tolerate a slightly higher voltage drop. However, the voltage drop should still be limited to no more than 5%. The NEC provides guidelines for calculating voltage drop in conductors. These guidelines take into account the length of the conductor, the size of the conductor, the type of conductor, and the amount of current flowing through it. By using these guidelines, electricians can determine whether the voltage drop in a particular circuit is within acceptable limits. Conductor protection is another important consideration in determining the maximum allowable distance between a panel and a transformer. Conductors must be protected against overcurrents, such as short circuits and ground faults. Overcurrents can cause conductors to overheat and potentially start a fire. The NEC requires that conductors be protected by overcurrent protection devices, such as circuit breakers or fuses. The size of the overcurrent protection device must be matched to the ampacity of the conductor. Ampacity refers to the maximum amount of current that a conductor can safely carry. The NEC provides tables that list the ampacities of different types of conductors. When a transformer is located a significant distance from the panel, it may be necessary to install additional overcurrent protection devices closer to the transformer. This is to ensure that the conductors between the panel and the transformer are adequately protected against overcurrents. The NEC also addresses the issue of tap conductors. Tap conductors are conductors that are tapped off of a larger feeder conductor. Tap conductors are often used to supply power to transformers. The NEC has specific requirements for the length and ampacity of tap conductors. These requirements are designed to ensure that the tap conductors are adequately protected against overcurrents and that the voltage drop in the tap conductors is within acceptable limits. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault currents to return to the source. This helps to protect personnel from electric shock. Bonding ensures that all metal parts of the electrical system are electrically connected. This helps to prevent voltage differences that could create a shock hazard. The NEC has specific requirements for grounding and bonding. These requirements cover everything from the size of the grounding and bonding conductors to the methods of connecting them. Proper ventilation is necessary to dissipate heat generated by the transformer. Transformers produce heat as a byproduct of their operation. If the heat is not properly dissipated, it can cause the transformer to overheat and fail. The NEC specifies minimum ventilation requirements for transformers to ensure that they operate within safe temperature limits. These requirements take into account the size of the transformer, the type of transformer, and the location of the transformer. Consulting a qualified electrician or electrical engineer is always advisable when installing a transformer. A qualified professional can help to ensure that the installation complies with all applicable NEC requirements and is safe and reliable. They can also provide guidance on selecting the appropriate transformer size and type for the application. Local codes may have additional requirements that supplement the NEC. It is important to check with the local AHJ to determine the specific requirements that apply to the installation. Special permission may be sought for exceptions to the NEC requirement. However, special permission is typically only granted if the installer can demonstrate that the proposed installation meets all applicable safety requirements, even though it deviates from the NEC. The 50-foot rule is a guideline intended to minimize risk, but practical considerations sometimes necessitate deviations. Seeking special permission involves a thorough review process by the AHJ. It requires detailed plans, calculations, and justifications to demonstrate that safety is not compromised. Alternative methods may be proposed to achieve the same level of safety, such as using larger conductors to reduce voltage drop or implementing enhanced overcurrent protection. Documentation is critical throughout the installation process. Maintain detailed records of all work performed, including conductor sizes, overcurrent protection device ratings, grounding and bonding connections, and ventilation provisions. These records will be valuable for future maintenance and troubleshooting. Regular inspections are beneficial for maintaining safety. Schedule periodic inspections of the transformer installation to ensure that all components are in good condition and that the system is operating safely. Inspections can help to identify potential problems before they become serious hazards. The location and environment where the transformer is installed also influence safety and code compliance. Transformers installed in damp or corrosive environments require special considerations to prevent deterioration and ensure reliable operation. Enclosures and other protective measures may be necessary to shield the transformer from the elements and prevent premature failure. Furthermore, the accessibility of the transformer is important for maintenance and repairs. The NEC specifies minimum working clearances around electrical equipment to provide adequate space for personnel to perform their tasks safely. These clearances must be maintained at all times, and the area around the transformer must be kept clear of obstructions. When selecting a transformer for a particular application, it is important to consider the load requirements. The transformer must be sized appropriately to handle the expected load without overheating or exceeding its capacity. Oversizing the transformer can lead to inefficiencies, while undersizing it can result in premature failure. A load calculation should be performed to determine the appropriate transformer size. This calculation takes into account the connected loads, the demand factors, and the diversity factors. Demand factors account for the fact that not all loads will be operating at the same time. Diversity factors account for the fact that the loads may not be evenly distributed across the transformer's secondary windings. In addition to the NEC, other standards and regulations may apply to transformer installations. These standards may cover topics such as energy efficiency, noise emissions, and electromagnetic compatibility. It is important to be aware of all applicable standards and regulations and to ensure that the installation complies with them. The NEC is constantly evolving to keep pace with advancements in technology and changes in industry practices. It is important to stay up to date on the latest revisions of the NEC to ensure that installations are safe and compliant. Continuing education courses and professional development programs can help electricians and electrical engineers stay informed about the latest code requirements. In conclusion, the 50-foot rule for transformer placement as per NEC 450.13 C is a key safety guideline. It is designed to minimize the risks associated with voltage drop, conductor protection, and overall system safety. While exceptions may be possible with special permission, strict adherence to the NEC and consultation with qualified professionals are paramount to ensure safe and compliant electrical installations.